Alright, so today's lecture is for Friday, May 29th. I hope everybody had a nice holiday, a nice break. I'm just looking ahead at the schedule, and it looks like we're doing well. In fact, we're probably a smidge, maybe like a day ahead. So what I might do for that review day, the day before the final, is try to set up at least a couple Zooms that week, because your final for this math is scheduled for Friday, June 12th. So the June 8th, I believe what I'll do is we'll definitely I'll have a couple Zooms scheduled as reviews. Okay, so drug calculations. All this math we've been doing kind of helps lead us to this. And this actually is covered under kind of bits and pieces of units 11, 12, 14, and 15 in your textbook. Don't worry about grains. Okay, we don't do anything with grains, G-R-A-I-N-S. Okay, so don't flip out about grains. We don't do that. That's pharmacies. They even do stuff in grains anymore. They probably do, but nothing that we have to deal with. Alright, so kind of a first couple slides here. This is a pretty short presentation today. Of course, it'll probably take me a little bit longer because I have to draw stuff out, but this is kind of overlaps a little bit with the science as far as talking about metric system, and remembering that our base units are liters, grams, and meter. Okay, so when you're looking at liters, you're looking at volume. Okay, so examples of that would be blood, urine, any other type of liquid. Okay, so liters being your base unit. So when you look at that King Henry died drinking chocolate milk or whatever, that base unit then is your liter. So you either go to milliliters or milliliters or centimeters or liters. Yeah, so that being your base unit. And then grams, I guess grams makes more sense to me as far as one that we do more so on weight, so that's kilograms, microgram, that type of thing. So that goes on either side of the base. So your base unit being gram, which is weight. So that can be an item's weight as in a person, or actually in milligrams or micrograms when you're talking about medicine. Okay, so different medications. And then meter being a length, so height, length, different instruments come in, like our endotracheal tubes, we measure those in centimeters. So again, meter being your base unit. So that's just kind of a little review of that. And so here are some of more of the common things that you are probably going to run across more than anything. These come from page 246 in your math book, unit 11. So a teaspoon is equivalent to about 5 mils or 5 milliliters. Ounce, 1 fluid ounce is equal to 30 mils. 1 milliliter then. Okay, so 1 mil is equal to 15 drops. And what that means is like approximately, depends on your drip rate on your IV tubing, but 15 drops is like a standard drop. So 15 drops would be equal to 1 mil. And then 1 kilo equals 2.2 pounds. We've talked about that before. And then 1 inch is equal to 2.54 centimeters. Okay, so those are some of your more common ones. Alright, so here's an example. Here's a problem that comes from page 247. And it's asking you then how many mils are in 2.5 ounces. Okay, so we're trying to solve for milliliters. So mils is going to be our X. So if we take a look at and try to set this up, so 30, oh my gosh, here we go, 30, there's 30 mils in 1 ounce. Okay, that's your conversion. I'm going to just say OZ. Okay, 30 mils in 1 ounce. So this is where we're looking at those proportions. And now we are trying to figure out how many ounces then, or how many mils rather, are in, so that's our X. So how many mils are there in 2.5 ounces? Sorry, 2.5. Oh my God, that looks awful. This should be 2.5, 2.5. Okay. So in order to figure this out, we would just take 30. Hold on one second. So we would just cross multiply then. Okay, so you have 30 times 2.5 is 75. So, and then you would divide that by 1, which would just still be 75. So your answer then is 75 mils. Hopefully that makes sense, because I think, okay, so I have 30 mils in 1 ounce. So I'm basically doubling it and adding another half of that. So if I double 30, I get 60, and then if I take a half of 30, that's 15, so 60 plus 15 is 75. Okay, so that's pretty straightforward, I think. So then here is your graph, or whatever you want to call it, that you've seen before, these little stair steps on looking at the metric value as far as how to decide if you're going to go to the left or to the right. Okay, so kilos are to your left. That's 1,000 of your base. This is your bench, would be your base. So depending if you're looking at grams, liters, or meters, depending which unit you're actually looking at, determine which way you're going to go with that. Okay. All right. So I have some different examples here. So that, so just want to there's kind of like a little rule, I guess. So when you're working from a big number to a smaller number, okay, your actual number will get bigger. Okay, so for example, if you're using ratio and proportion format to convert rather 2 kilograms to grams, okay, so even though grams are a smaller unit, okay, than a kilogram, the number itself is going to be bigger. Okay, so we're looking at gosh, I have such a short-term memory, I can't remember. I know I have a blank slide here, but let's just go ahead and look at this one first. I'm pretty sure I left it blank to work this out. But so if we're looking at trying to figure out then how many grams are in 2 kilograms, well, 1 kilogram is 1,000 grams. Okay. So we got 1 kilo equals 1,000 grams. Okay. So that's why I'm saying you're going to a smaller number, but the number itself, a smaller unit, maybe that should say, your number is going to get bigger. Okay, so then when you go for 2 kilograms, obviously you're going to double this. So 2 kilos are going to be 2,000 grams. And just to kind of put some things in perspective for you, so we weigh, so remember 2.2 pounds per kilogram. Okay, so we actually have babies that weigh less than a kilo. So they're obviously they weigh less than 2.2 pounds. So they actually weigh them in grams. So you may see a baby that's like 800 grams or 900 grams. So that's less than a kilogram, which is definitely less than 2.2 pounds. Teeny tiny, very premature. Okay. All right. So then when you're working from a small number, okay, to a bigger, I should really maybe change that to unit. Then your number is going to get smaller. So you're looking at 3,000 mils. And maybe before I upload this, I will change that to the PowerPoint part that you can look at without the audio. In fact, I do have that crossed out here as I'm looking at my notes. So you're looking at going from 3,000 mils to liters. Now, a milliliter is teeny tiny. A mil is like in a syringe. You look like a syringe, and those are in milliliters. Okay, so 3,000 mils to liters. So that would be then 3 liters is 3,000 mils. So let me go to the next slide here, because I'm pretty sure I gave myself, yes, this is what I thought I had kind of started this. So we already talked about going from kilos to grams. So if we're looking at 1 liter, okay, and we want to figure out, so we have 1 liter equals 1,000 mils, okay. Mils are a smaller unit, and we want to know how many milliliters then would be in 3 liters. So that would be 3,000 mils. So we just cross multiply again. So you have your units right across from each other. So liters to liters and then mils to mils. So then this would give us 3,000 mils. So I think this kind of conversion stuff is pretty straightforward. Alright, so these are things you definitely want to memorize. These are things that you're going to want to know. Okay, your grams and your liters and milliliters. Alright, so here is an example of how we could apply this. So we have, I'll leave this paper out so I remember to change those units. So here's an example of, you have a resident is on a sodium restricted diet and is limited to 1,500 milligrams of sodium each day. A whole grain cracker has 0.16 grams of sodium. How many crackers can she eat and stay below the 1,500 milligrams of sodium? So the thing you should notice right away is that you're talking about 2 different units of measurement. Okay, you're looking at milligrams is how much she's allowed each day, 1,500 milligrams, and then each of the crackers though has 0.16 grams of sodium. Okay, and I think I have a couple blank slides here for this. So let's go to, and then we'll go to the next problem. All right, so we're trying this again. I've had to re-record this a couple times. All right, so we have 1 cracker. Okay, I'm just going to do CR for cracker. Equals 0. I think she's going to bark. Crazy dog. I don't know why she always comes in here when I'm recording. Maybe she feels that she doesn't want me to talk to myself. Okay, so 1 cracker has that much. Okay, but we are going to, I would like to know how many milligrams is that. Okay, so that's 0.16 grams. Grams being my base. Okay, I know that 1,000 milligrams is in a gram. So that means I'm going to move 3 decimal places over to the right. Okay, so if I look at it this way, I have 1,000. I'm trying to decide if I would do better with really teeny tiny, even though this isn't super teeny tiny. So remember, we have 1,000 milligrams in 1 gram. Okay. So we want to know how many milligrams is that. And we know that we have 0.16, don't Maggie. Okay, so we have 0. That's my dog. 0.16 times 1,000. Okay, so like I said, we'll move 3 decimal places over to the right. So that gives us 160 milligrams per cracker. Okay, that's what we really want to know. Okay, now we are going to say that one cracker. We're looking at this problem a little bit differently. Just making sure we're using the same units. One cracker equals 160 milligrams. And we want to know how many crackers is that in 1500 milligrams. Okay, so this is 1500 milligrams, and we're trying to figure out how many crackers we can have. Okay, so we're going to take 1500, we're going to multiply 1500 by 1. So we're going to have 1500 basically divided by 160. So we're going to do the cross multiplication. 1500 would be in your house, and you would divide that by 160. So much, I'm running out of room here. So cross multiply and then divide by 160. And you're going to have approximately, when you do your math, approximately 9 crackers. Okay? So it helps to go ahead and convert it to the same unit so that when you get your answer, you're already there in those for converting back from crackers to milligrams. Alright, hopefully that wasn't too terribly awful. Okay. Now we were going to take a look at the next problem. And I think I messed up by not giving myself 2 blank slides. So let's see if we can do this one in dark blue. To do it the right order there. Okay, so this one was cough syrup has 5 milligrams in 1 ml. So then how many milligrams of medication are there in 20 mils? So if cough syrup has 5 milligrams of 5 milligrams in 1 ml, okay, so that's like our known, 5 milligrams of medication, 1 ml, we want to know how many milligrams then are in 20 mils. So that's what the second part of that question was asking. Okay, so cough syrup has 5 milligrams of medication, 1 ml solution. How many milligrams of medication are in a 20 ml solution? So 5 milligrams to 1 ml is the same as how many milligrams to 20 mils. Again, cross multiply. 20 times 5 is 100. You're not divided by 1, so you're still at 100. So your answer then for that one is 100 milligrams per 20 mil. So it's the same concentration, it's the same solution, just probably having to be a bigger dose, usually based on weight. Okay, so 5 milligrams to 1 mil is the same as 100 milligrams to 20 mils. All right, hopefully that makes sense. So that was part 2 of that one. Okay, this is just being your last slide, and where I just kind of want to mention that in charting, and of course everything is, you know, computerized now, but back in the day it was always helpful too, just to kind of make sure that you put that 0 before that 0.5 on the grams, mainly because you're just verifying and affirming that there is no other number before the 0.5. So it's not like it was supposed to be 1.5 and you just forgot to put the 1 or whatever. So 0 is just making sure, saying yes, it is indeed 0.5. Okay, and because a lot of our charting is computerized, it's sometimes just are automatically figured out that way. So we're just going to stop here today, mainly because the next part, once we kind of start with it, we really have to go with it, and we'll be looking more at drug calculations and a little bit more complicated. So I just kind of want to talk briefly about your assignment, your homework then. let's see, I had this written down, and now yes, it is on page, let me see here. So this first part isn't too terribly hairy. Yeah, page 251 and 252, you're looking at problems 2 through 20. You're doing a lot of converting from, it's all liquid conversion. So you're looking at mils to ounces, teaspoons to mils, mils to teaspoons, back and forth, tablespoons to milliliters. So use the numbers that I had shown you on the previous slide. And again, it's on page 246. Don't worry about the greens. We're not going to be doing those types of problems. And then on page 257 and 259, it's actually kind of towards the end of the chapter. It's just the even numbers 2 through 14. Okay, and make sure you're looking carefully. A lot of the word problems have to do with the picture or the label of the medication that they're referring to is listed above it. So some people don't seem to see that sometimes, but make sure you're reading your problems carefully. And then we'll be digging a little bit deeper next time. All right, as always, email me with questions, please.